Good day, class. Before we proceed to our new lesson for today, let us define trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And of course, the different parts of a trapezoid are the parallel sides of a trapezoid are called the bases, and then we have the non-parallel sides are called the legs, and then the angles formed by a base and a leg are called the base angles. Our last topic is all about the median of a trapezoid. Now, what if the legs of the trapezoid become congruent? What must be true about its base angles and its diagonals? On this video, our topic is all about theorem on isosceles trapezoid. But before that, let us define isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So we have here similar markings to indicate that the legs of our trapezoid are congruent. Then we have theorem on isosceles trapezoid. The first theorem, or theorem number 7, the base angles of an isosceles trapezoid are congruent. Next, theorem number 8, opposite angles of an isosceles trapezoid are supplementary. Next, theorem number 9, the diagonals of an isosceles trapezoid are congruent. Let's start our discussion on theorem 7, which is the base angles of an isosceles trapezoid are congruent. So in our figure, angle AMH is congruent to angle MAT. And angle MHT is congruent to angle ATH. So if we have angle AMH is equal to 145 degrees, then the value of our angle MAT is also 145 degrees based on theorem 7. And then another, if angle MHT is equal to 35 degrees, angle ATH is also 35 degrees. Let us proceed to theorem 8. Opposite angles of an isosceles trapezoid are supplementary. Do not forget that if we have supplementary, it means we have two angles measures 180 degrees. Like this, the measure of angle AMH plus the measure of angle ATH is equal to 180. And another, we have angle MHT plus the measure of angle MAT is equal also to 180 degrees. If we have angle MHT, which is 25 degrees, then let us solve for angle A, or angle MAT. Let us substitute the value of angle MHT, which is 25, and then plus the measure of angle MAT equals 180. Then after that, all you have to do is to substitute or to transpose 25 to the right side of the equation, so it becomes negative 25. Then subtract, so the final answer is the measure of angle MAT is equal to 155 because they are supplementary angles. Now, in this example, let us solve for the value of x. Okay, for the first one, do not forget that we use theorem number 8, wherein the opposite angles of an isosceles trapezoid are supplementary. So instead of using equal sign, we use 180 degrees. So like this, we have 28x minus 11 plus 51 equals 180. Then, we will combine like terms. Negative 11 plus 51 is equal to positive 40. So as you can see, we have now 28x plus 40 equals 180. Then we will transpose positive 40 on the right side of the equation. So we have 28x equals 180 minus 40. Then subtract. So we have 180 minus 40 is equal to 140. Then let us divide the both sides of the equation by the numerical coefficient of x, which is 28. So we have 28x divided by 28 and 140 divided by 28. So the value of our x is equal to 5. Now, let us proceed to the second figure. We have isosceles trapezoid math. So we will use the theorem number 7, which is the base angles of an isosceles trapezoid are congruent. So we use equal sign here. So we have 4x plus 1 equals 2x plus 39. And then we will transpose positive 2x on the left side of the equation. It becomes negative, while positive 1 on the right side, so it becomes negative 1. So we have 4x minus 2x equals 39 minus 1. So subtract, then we have 2x equals 39 minus 1. So we have now the equation 2x equals 38. Then let us divide the both sides of the equation by the numerical coefficient of x, which is 2. So 2x divided by 2 and then 38 divided by 2. So the value of our x now is equal to 19 because 38 divided by 2 is 19. Now let us proceed to theorem number 9, that the diagonals of an isosceles trapezoid are congruent. So based on the figure, we have isosceles trapezoid math. Okay, so we have the diagonals are line segment MT and line segment AH. So based on theorem number 9, we have line segment MT is congruent to line segment AH. So diagonals are congruent. This is an isosceles trapezoid. And using this point S, we form two pairs of congruent segments. The first one is line segment MS is congruent to line segment AS. Then the second pair is line segment HS is congruent to line segment TS. And then let us solve this one. The given is AH is equal to 4y minus 3, while MT is equal to 2y plus 5. So we have HA and MT as our diagonals. So for the letter A, what is the value of y? And then for letter B, how long is each diagonal? That is the problem. Okay, first let us solve for the value of y. So as you can see, because based on the theorem, the diagonals of an isosceles trapezoid are congruent. So if the two diagonals are congruent, it means their measure are equal. So we have to use the representation of AH, which is 4y minus 3, and then the representation of MT, which is 2y plus 5. So we have 4y minus 3 equals 2y plus 5 as our equation. Then after that, we will combine like terms. So on the left side, we have 4y minus 2y because as you can see, 2y we will transpose it to the right or to the left rather. So it becomes negative. While this negative 3, we will transform it to the right side of the equation. So it becomes positive 3. And then for y minus 2y is 2y, while 5 plus 3 is equal to 8. Then divide the both sides of the equation by 2, and that is y is equal to 4. Now let us solve for the value of AH. We have AH is equal to 4y minus 3. Again, we will replace this y with 4. So we have AH is equal to 4 times 4 minus 3. Then we have 16 minus 3. We write negative 3. And then we have 13 units. So the value of our AH is equal to 13 units because 16 minus 3 is 13. And then let us solve for the value of MT. mt is equal to 2y plus 5. So we have here. Then again, using 4, we will replace y with the value of y, which is 4. So we have mt is equal to 2 times 4 plus 5. 2 times 4 is equal to 8 plus 5. Then 8 plus 5 is equal to 13 units. Okay, so that is our theorem number 9 of an isosceles trapezoid. And that's the end of our video. Thank you. I hope you can get helpful knowledge from this presentation. Goodbye and God bless.